Hello everyone, welcome to this session. In this session, I will explain Lagrange interpolation method and its theory and its Python code. So let's start. The Lagrange interpolation formula finds a polynomial called Lagrange polynomial that takes on certain values of an arbitrary point. It is an nth degree polynomial expression for the function say f of x. The interpolation method is used to find the new data points within the range of a discrete set of known data points. Lagrange interpolation is a way of finding the value of any function at any given point when the function is not given. We use other points on the function to get the value of the function at any required point. Suppose we have a function say y is equal to f of x in which substituting the values of x gives different values of y. We are given say two data points, that is x1 y1 and x2 y2 on the curve. Then the values of y at x is equal to a, which is a constant, is calculated using Lagrange interpolation formula. Here I have written Lagrange interpolation formula. Given few real values say x1, x2, x3 up to xn and y1, y2, y3 up to yn, and there will be a polynomial say p with real coefficients satisfying the conditions pxi is equal to yi, whereas I is equal to 1, 2, 3 up to n, and the degree of polynomial p must be less than the count of real values, whereas degree of p less than n. The Lagrange interpolation formula for nth degree polynomial is given below. Say f of x is equal to x minus x1 into x minus x2 up to x minus xn divided by x naught minus x1 into x naught minus x2 up to x naught minus xn into y naught up to x minus x naught into x minus x1 up to x minus xn minus 1 divided by xn minus x naught xn minus x1 up to xn minus xn minus 1 into yn. This is the formula of Lagrange interpolation method. Okay. Next, I have written the Lagrange first order interpolation formula. If the degree of the polynomial is 1, then it is called first order polynomial. Lagrange interpolation formula for first order polynomial is f of x is equal to x minus x1 divided by x naught minus x1 into y naught plus x minus x naught divided by x1 minus x naught into y1. And next I have written Lagrange second order interpolation formula. If the degree of polynomial is 2, then it is called the second order polynomial. The Lagrange interpolation formula for second order polynomial is f of x is equal to x minus x1 into x minus x2 divided by x naught minus x1 into x naught minus x2 into y naught up to plus x minus x naught into x minus x1 divided by x2 minus x naught into x2 minus x1 and into y2. This is the formula of Lagrange second order interpolation method. I think this is clear to you. Next, I have written properties of Lagrange interpolation formula. Various properties of Lagrange interpolation formula are discussed below. First is, this formula is used to find the value of the function at any point even when the function itself is not given. And number two is, it is used even if the points given are not evenly spaced. And number 3, it gives the value of the dependent variable for any independent variable belong to any function, and thus is used in numerical analysis for finding the value of the function. Next, I have written the uses of Lagrange interpolation formula. Various uses of Lagrange interpolation formula are discussed below. The first is it is used to find the value of the dependent variable at any particular independent variable even if the function itself is not given. The number 2 is it is used in image scaling. The number 3 is it is used in AI modeling. And number 4 is it is used to teach NLPs, etc. I think this is clear to you. Next, I have written some numerical problem based on Lagrange interpolation method. The first question is consider the given datasets where the x values are given -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5, and the corresponding f of x values are 13.3, 19.8, 10.9, 4.64, 1.09, 0.00, 0.89, 3.04, 5.49, 7.04, and 6.25. And it says that use Lagrange interpolation method to find out f of 2.5, plot the data along with interpolated points using matplotlib and label the axis and set appropriate legend at suitable location. And the second question is using Lagrange formula, write a Python code to find the value of f of 50 from the following table where the x values are given, that is 15, 30, 45, 60, and 75, and the corresponding f of x values are 0.268, 0.577, 1, 1.732, 3.732, and compare your result using any one-dimensional interpolating function from NumPy or SciPy. Using matplotlib, plot the data points as f of x versus x as red rings. Also show the interpolating function in the same plot, use appropriate labels and legend, and mention the value of f of 50. I hope you will solve this question yourself after I will show you its Python code. So let's see its Python code. Here I have written its Python code. As usual, at first I import some packages, that is import numpy as np, from scipy.interpolate, import Lagrange, and import matplotlib.pyplot as plt. Next I have written the given data points, that is x is equal to 30, 45, 60, 75, 90, and the corresponding y values are 0.866, 0.707, 0.5, comma 0.259 and 0. This is the given data points. Okay, and next I have taken a new variable, say n, that is n is equal to len of x, that means the length of the x list. Next I have input xp, that xp is equal to float input, enter the interpolation point. Okay, next I have written the Lagrange interpolation method. First I have taken a new variable, say yp, that is I have taken, that is yp is equal to 0, and then I have take a for loop, say for I in range 0 comma n. Here I have taken first p is equal to 1, and then for j in range 0 comma n, then if I is not equal to j, then p taken is p is equal to p into xp minus x j, jth element, divided by x ith element minus x jth element, and then plug in the y values, that is yp is equal to yp plus p into yi element. Okay, in this way I have written the Lagrange interpolation method. Okay, next I use scipy for interpolating points and say poly. It is a new variable I have taken as poly, that is poly is equal to Lagrange x comma y. Please note that this comment returns the Lagrange polynomial. Okay, that is Lagrange x comma y. Next I have taken a new variable, say x vals, that is x vals is equal to np dot linspace 30 to 90 comma 100. Here 30 is the lower limit and 90 is the upper limit and 100 is the number of points taken within the range 30 to 90, and then y vals is equal to poly x vals. Okay, if you have any doubt in this comment, just print it out. Okay, and next I have print the Lagrange interpolation, that is print Lagrange interpolation, that is yp. That means yp is the value of the interpolation point by using Lagrange method. Okay, next the value of y at point xp using scipy, that is poly xp. And finally print the scipy polynomial, that is Lagrange x comma y. Okay, next I have plot the data points and the interpolation point and the polynomial in a same plot, that is plt dot plot x comma y, plt dot plot xp comma yp, plt dot plots x vals comma y vals, and the different levels for these three plots, and finally plt dot show for showing this plot. Okay, so let's run this code. Here I have taken the interpolation point, say 85, okay, and just enter it. You see that the Lagrange interpolation value is approximately 0.087, and the value of y at point xp, that means the interpolation point using scipy, is also approximately 0.87. That means these two values are equal, so this is the correct. Then the polynomial is scipy polynomial, x to the power 4 plus x cube minus 0.0017 x square and plus 0.00058x and plus 0.994. This is the scipy polynomial, and I have plotting the polynomial also. Here you see that the x-axis are labeled as x, the y-axis is labeled as f of x, and the red circle shows you the data points and the star point shows you the interpolation point, and the black dotted line shows the polynomial. Okay, I think this is clear to you, and thanks for watching this video.